Hello viewers, today 6th September the year 2023, Wednesday, we are going to solve some calculus question, part 3a of the. Now this is our video. This is our last video for the topic calculus. But before we dive to the questions, we are going to show you some steps on how to increase the speed of any downloaded video when you're watching in the YouTube application. Okay. For one to enjoy the speed of any video in YouTube, you have to follow the steps. The following steps can assist you know how to watch and enjoy videos in YouTube. For example, the first step we say we open the YouTube video. You open the YouTube application. I have already opened, as you can see. I have already opened the YouTube application. Then after opening, you choose any of the video you need to download. You download it. I have already downloaded some videos. After downloading the videos, then you choose, for example, for me, I choose this. If you click the video, as you have seen, you click it once more, then it will give you there is a place here. There is a place showing a star. If you see this small star here, you click it. After clicking the small star, you will see a place written. This place, it is written playback speed. You click it. After clicking the playback speed, you can choose any speed which, like this one. This I have chosen normal, but you can choose the second one. Okay, it has zoomed. You can choose. We are going to playback speed. It is written normal here, but I can either choose that one. Now that is another speed. As you can see, the video is zooming at very high speed, and if you hear the sound, it is more faster than the previous one. You can go back to the playback speed and click it. If you click the playback speed, you can choose, for example, this one. If you choose that one, you realize that one is very small. If you go back and click the star there, you are going to playback speed. After going to playback speed, you hear that the sound is very slow. Then you go to, for example, I choose this. You can hear that the sound is very, very fast. It's very fast. If you click back the screen, you go to this where the star is. You see, this is the star, up 100. Then you go to playback speed. You click playback speed. You choose any speed you like let's say 0.75x, this speed. Here the speed is different from the previous one. If you click the screen, you click the screen once, it will bring the star. You click the star, it takes you back to the playback speed. Click the playback speed, then you choose any speed you want. For example, if I like 2x, you will hear 2x. here this. Okay, I think that is enough for today. You can make it your own practice. We are going to question number 11 of the calculus part 3b, part 3a, sorry. For the question, we say that the question states that a square sheet of metal has an area of 100 meters square. An open rectangular tank is to be made by cutting equal squares from the corners and bending the sides up. Find the height of the tank for which the volume will be maximum 4 max. Okay, for this question we say solution. After saying solution, we are going to identify whether this, we have to know that is it an integration or a differentiation question. For this case, this is an integration question because we are looking for or calculating volume of objects. For more detail about acceleration for more details about integration or differentiation, see my summary tips on the previous video. Remember this question is opposite of question number 7. See it from our previous video. So for the case, let the small square. For this case, I have also demonstrated the diagram from the information given. I have demonstrated a diagram after my solution. These are the diagram. We see that the sheet of metal is this, and this is the sheet of metal, and we were told that it is 100 meters square. An open rectangular tank is to be made by cutting equal squares from the corners. As you can see, these are the small squares which are cut from the corners, which the length is not given. Then we say the length is x. From this the sheet of metal becomes this way. Then after bending the corners, it looks like this. This is the initial sheet because we have cut the corners, this corner, and the length of the corners cut are unknown. That's why we have labeled it x. Therefore, we say let the small squares cut from the corners, each of their sides be x meters. Then the tank dimension of the tank dimension will be 10 times brackets length of one side of the square, which is in meters, minus the unknown length from the two corners of one side, minus the unknown length from the two corners of one side, which is x plus x into brackets meters, multiplied by height, multiplied by height, multiplied by height, multiplied by height, height which is unknown, which is this height is unknown. Then we proceed as now. From this information, we can translate it as, we can further translate it as 10 minus brackets x minus x into brackets times x, which will further give us 10 minus 2 brackets 2 minus x into brackets times x. Now, if the length of one side is 10 minus 2x into brackets meters, considering the information above, it's a square cube, hence the base length must be the same. Therefore we say volume is equal to length times width, which is equivalent to, this will be equivalent to 10 minus 2x into brackets times 10 minus 2x into brackets times x. By expanding 10 minus 2x into brackets times 10 minus 2x times x, the volume will be 100x minus 40x squared plus 4x power 3. Now here we say that, here we are going to say change in volume over change in length x over change in length x is the same as 0, which is equal to 100 minus 80x plus 12x power 2. After solving this, you get this value. After solving the quadratic equation using quadratic formula, you will get, after solving this is 10, this is 100 minus, this is quadratic expression, not really, this is quadratic equation, which is 2x squared plus, not really, minus 80x, sorry, this is 2x squared plus 80x minus 100 is equal to 0. This is a quadratic equation. Now, after solving this quadratic equation by using any formula or the quadratic formula, you are going to realize that you get x as 5 or 1.67, which is in meters, and this will be the height of the tank, which the volume will be maximum. it is 5 or 1.67 meters. And this is the required answer. This is the required answer. You should be very keen on our working. This is how the question I have worked it. You can just follow it. This is how we have worked question number 11. Then we are going to question number 12. Question number 12 states that a closed cylindrical container designed such that its volume is 250 pi centimeter cubed is made from a metal sheet. Find the radius of the container, which will require a minimum area of metal sheet. 4 marks. Okay. Note that wherever you see maximum or minimum area in either land, sheet of metal or woods, it's a differentiation question. Therefore, for this case, the surface area of the cylinder is in relation to its volume by substituting with the value given with both the surface area formula of a cylinder and the formula for the volume of a cylinder. Therefore, surface area of the cylinder is given by 2 pi r squared plus 2 pi r h, and volume is given by pi r squared h, which the volume, in the case our volume is given as 250 pi. Is given as 250 pi. Hence, if pi r squared h is 250 pi, therefore we are looking for r. Hence, we are going to divide both sides by pi. If we divide both sides by pi, pi goes. We are remaining with r squared h is the same as 250. We are going to divide both sides by r squared. R squared by r squared. Divide by r squared. This will further give us r squared goes, remaining with h is the same as 250 r squared. H is the same as 250 r squared. This will further give us, by substituting h in the surface area formula, we are going to get that it is like, we are going to notice that 2 pi r squared plus 2 pi r times our h, which is 250 over r squared. This will further give us 2 pi r squared plus 2 pi r times 250 over r squared. This will further give us 2 pi r squared plus 2 times 250 pi r over r squared. This will further give us 2 pi r squared plus 500 pi r over r squared. If we divide r by r squared, we are going to remain with the r. Hence, this will give us 2 pi r squared plus 500 plus 500 pi over r. This will further give us 2 pi r squared, 2 pi r squared plus 500 pi, which is equal to r, because 500 pi over r, because 500 pi over r is equivalent to, this is the same as 500 is equal to r because of the division sign there. Now, if r crosses the equal sign, becomes negative, it will affect the whole equation. Hence, it becomes, this will give us 2 pi r squared minus 500 pi r power negative 1. By differentiating this, we are going to get 4 pi r minus 500 pi r squared, but the power is negative, which will be equal to change in area over change in radius. Hence, this will give us dA over dr will give us 4 pi r minus 500 pi over r squared, but for minimum area, dA dx, for minimum area, the dA dx must be 0. Therefore, we say change in area over change in radius in minimum must be 0. Therefore, we're going to say that this is question number 12. It continues as, we're going to say that this question is a little bit long. We say 4 pi r minus 500 pi over r squared is equal to 0. Therefore, we say 4 pi r minus 500 pi over r squared, we are going to multiply by r squared. R squared is equal to 0. This will further give us 4 pi r power 3 minus 500 pi is equal to 0. Therefore, 4 pi r power 3 minus 500 pi is equal to 0. We are going to divide through by pi. If we divide through by pi, we are going to remaining with 4 r power 3 minus 500 is equal to 0. If we divide further by 4, if we divide the row by 4, we get r power 3 is equal to we are going to get by 4 1 by 4 125. Therefore get r power 3 is the same as 125. Now to get the value of r, we have to find the cube root of 125. The cube root of 125 by using either logbook or calculator is 5. Therefore, from the question, you should see the working. This is how we have worked the question. For the question, they are asking for find the radius of the container which will require a minimum area of metal sheet. The radius of the container is 5 centimeters. Okay, it has given 5 centimeters. The radius of the container is 5 centimeters. This is the answer. This is the required answer, and this is our working. This is our working. We are going to question number 13. Question number 13. Question number 13 states that Question number 13 states that a man has 140 of wire mesh with which he intends to fence a rectangular enclosure for rearing hens. Find the length of the enclosure which will give maximum area. Hence, calculate this area for max. I think, as you can see from our previous questions and they are working, we are now in question number 13. This is question we have done with question number 11 and question number 12. As you can see, we are in question number 13. As you can see now, for question number 13, this is a differentiation question, because we have been asked to find a man has 140 meter of wire mesh which he intends to fence a rectangular enclosure for rearing hens. Find the length of the enclosure which will give a maximum area, and hence calculate the area for max. Okay, this is a differential question defined by the term maximum area. Therefore let the length of the required and the width required be W. Let the length be L and the width required be W. The rectangle enclosure with the total length 140. This defines perimeter. Hence, we say solution. We say if this is the rectangular plot and we are told that it is the enclosure to close the length of the wire is 140 meters, and we know that the perimeter of the perimeter of a rectangle is given by 2 into brackets L plus width, which is 140. That is the perimeter of any rectangle. Now we say that, but for this case, we need the length. Hence, we are going to say that because we need the length, we say 2 into brackets length plus width into brackets divided by 2, which is equal to 140. We are going to divide by 2 to remove. If we divide by 2 is 70. Because we need the length in maximum area, we have to find width first. Now our width is 70 here, because our width is 70, because we say length plus width is the same as 70. Therefore, our width will be equal to 70 minus L. Note that by finding the width first, it's the only way of differentiating the length. But we know that area is the same as length times width. Hence, length times into bracket 70 minus L, which is the same as, this will further give us 70L minus L squared. Now this will further give us, by differentiating length, we say change in area over change in length, which will give us 70L minus L squared. This will further give us, because we are differentiating, we say 1 times 70L, L is power 1 minus 1 minus 2. Here L is power 2 minus 1. This will further give us 70 minus 2L, 70 minus 2L. But we know that for maximum area, we have differentiated. We know that for maximum area, change in area over change in length is 0. Therefore, we say dA over dL is 0. Therefore, here we say 70 minus 2L is equal to 0. 70 is equal to 2L. If you divide both sides by 2, get L is 35. L is 35. Therefore, the area required, if our length is 35, the area required will be, if our length is 35, hence the area required will be is derived from the initial equation. From our initial equation, it was 70. This was our initial equation. Area was equal to 70L minus L squared, which is equivalent to this one. This is our initial equation, which this will be equivalent to 70 times 35, which is this length, minus into brackets minus 35 squared, which will finally give us 70 times 35 minus 35 squared. This is 35 squared. This will finally give us 1,225 meters square, and this is the required answer. This is the required answer, and that is how we calculate such a question in question 13. That is question 13. Now question 14. For question 14, we are going to solve question 14. Question 14 states that a particle P moves in a straight line such that t seconds after passing a fixed point Q, its velocity v meters per second is given by the equation v is equal to t squared minus 7t plus 12. Find the value of t when p is at rest 2 Mach. B, an expression for the distance s in meters moved by the particle p after t seconds 1 Mach. C, the total distance traveled by p in the first 3 seconds after passing Q 3 Mach. And D, the distance of p from Q when acceleration is 0 4 Mach. Okay, for this kind of question, we are going to tackle it as follows. Okay, we know when the particle is at rest, then its velocity is always 0. Therefore we say velocity is 0. Hence velocity is equal to t squared minus 7t plus 12 is equal to 0. The function is in quadratic in nature. Then we are going to use any quadratic formula method. Note that this is the only type of question in which you are not required to integrate or differentiate in calculus at its first part of the question. Therefore, we say t squared minus 7t plus 12 is equal to 0. We are looking for two numbers in which we are going to give us sum as -7 and product 12. This is 12, which the two numbers or factors are -3 and -4. Therefore, we say that we are going to say t squared minus 7t plus 12 is equals to 0. Hence, t squared minus 3t minus 4t plus 12 is equals to 0. Hence, t from this quadratic equation, we are going to factor out t there because it is common. We say t into brackets, t minus 3 into brackets. Now for 4 will be common in both 12 and 40. Therefore, we are going to factor it out 4 as 4 into brackets t minus 3, which is same as is equal to 0, because 4 is both common in 40 and 12. Hence say t minus 4 into brackets. We are going to, since t minus 3 and t minus 3 are common, we are going to take one, t minus 3, then t minus 4 into brackets t minus 3, because t minus 3 is seen to be common. Therefore, we say this is equal to 0. Hence, this will be t minus 4 is equal to 0, which will give us t minus 4 is equal to 0 is the same as t is equal to 4, and t minus 3 is equal to 0 is the same as t is equal to 3. Therefore, this means the particle is at rest. This means the particle is at rest. We have the t is time in seconds. Hence, time is 4 seconds or time is 3 seconds. Now, for our first question, find the value of t when p is at rest. We get the value of t when p is at rest is at t is 4 or t is 3 or t is 4, and these are in seconds. This is the required answer, 3 or 4. This means the particle is at rest between 3 and 4 seconds respectively, and these are the answers for part A. For part B, okay. For part B, we have to remind ourselves that for the question in part A, because we are going to meet several questions concerning, but these are the answers. But there is a little hint here. For question number 14A, we know when calculating calculus question under differentiation and integration, the question could be asking displacement, velocity, or acceleration, or even dy dx in form of the gradient of a curve. Note that you are given displacement. When you are given displacement and you need velocity, you differentiate displacement to get velocity, and if you are given acceleration, you want velocity, you integrate Second, if you are given differentiation, you are to differentiate velocity to get acceleration. If you are given velocity and you need displacement, you integrate. If you are at acceleration and you need displacement, then you need to integrate the two times. For more about this, see my tips summary. is well explained. Hence the formula goes like, we are going to write it in short as S for displacement, velocity, acceleration, and dy dx. This is our short summary, but if you want to know more about it, you can just see it on our tips. See it on our tips. You are going to solve question number 14b. We are going to solve question number 14b on this. This is 14b. We are going to solve it here in this paper. Here is where we're going to solve. Now for question number 14b, we are told that find an expression for the distance s meters moved by p as t after t seconds. Find an expression for the distance s meters moved by p after t seconds. 1 mark. Okay, for this distance here means displacement. Hence, if you have velocity and you need displacement, you integrate the velocity function. See it in the formula tips. Hence, we say for our number 14b, we say velocity is the same as t squared minus 7t plus 12. Now, to get displacement, you have to integrate the velocity equation above as v is the same as t. It is this equation. Then we are going to say that velocity we are going to integrate as t squared into bracket. This is the sign for integration. T squared minus 7t plus 12 into brackets dt. We integrate the velocity function with respect to change in time. Hence, we say our t is squared here. Then we say t plus 1. This will be t over 3 minus 7t is power 1 plus 1 will be 7 over 2 plus 12t, because we are integrating. Therefore, we say t power 3 over 3 minus 7t squared over 2 plus 12t over 1, because t is power 1, plus our c, which is the constant of integration. T is the constant, c is the constant of integration. But we know that when time is 0, our displacement will be 0, or when displacement will be 0 when our time is 0. For this reason, it will affect the constant to be 0, or our c will be 0. Our c will be 0. Therefore, we say our distance will be t power 3 over 3 minus 7t squared over 2 plus 12t. And this is the required expression This is the required expression, and it is the answer for part B of question number 14. This is how it should be worked, and that is the answer. This is the answer for part B of the question. Now for part C, question number 14C states that from the statement, it states that question number 14C, the total distance traveled by P in the first 3 seconds after passing point Q, 3 marks. This is a 10 marks question. This is the 10 marks question, and mind you, if you get 10 marks in maths, I think you will be out of an E in an exam. Question number 14C states that the total distance traveled by P in the first 3 seconds. This one will be, here we are going to take the final displacement expression, final answer in part 14B, which is S as distance, which is 3 power 3 t power 3 over 3 minus 7t squared over 2 plus 12t. Then we say at t 3 seconds, the displacement will be, S will be 3. We substitute time t with 3 for 3 seconds, power 3 over 3 minus 7 to bracket 3, which is squared into brackets, plus 12 to brackets 3. This will further give us, this will be 27 over 3 minus 63 over 2 plus 36. This will further give us 9 plus 36 minus 3. If we divide this, we get 31.5 minus 63 divided by 2 is 31.5 minus 31.5, which will finally give us, this will finally give us 13.5, which is in meters, 13.5 meters, because we have, for question number 14C, the total distance the total distance traveled by P in the first 3 seconds, which is 13.5 meters. That is the answer for question number 14C, which is 3 marks. We are going to solve question number 14B. We are in D, sorry. Question number 14D states that from the original question, question number 14D states that the distance of P from Q when acceleration is 0, 4 marks. I think you are following me. This will further give us, because question number 14D, they are asking for distance. We have been given the velocity function to be V is the same as the initial velocity minus 7t plus 12 from our initial. Now for question number 14D, we are going to use the equation from our initial expression given. So we have been given the velocity function to be this, then we need acceleration. Therefore, we need to differentiate velocity to get acceleration. Hence, velocity will be, if you differentiate this equation, we get 2t minus 7. If you differentiate this equation, get 2t minus 7, which will give us 2t minus 7 over 2 over 2. This will further give us, if we divide both, this is 3.5. Hence, t is 3.5. Therefore, the acceleration, hence the acceleration 0 when it's 3.5 seconds. Therefore, the distance or displacement here, to get it, you have to substitute time t, which is 3.5 seconds, to displacement function, which is the expression in part B, which is the expression we have got it in this part B, which is if you go back to the video in part B, our expression was displacement or distance was power t power 3 over 3 minus 7t squared over 2 plus 12t. Now, if we substitute 3.5 here, see as 3.5 power 3 minus 7 into brackets 3.5 into brackets times 3.5 into brackets plus, this is 12t times 3.5, because our t is 3.5. Hence, this will further give us, that one will give us, by using calculator for our question 14D here, by using calculator to calculate this, you are going to get our distance as 14.29 minus 42.88 plus 42, which will further give us 14.29 plus 14 minus 42.88, which will further give us, this will further give us 13.41 meters, and this is the distance. This is the distance of P from Q when acceleration is 0. 4 marks. This is the answer required. Please, we have already finished question number 14. Please subscribe, click the small bell once, download, then share to your friends and relatives. We are in question number 15. Question number 15 states that, question number 15 states that a diver leaps from a diving board 32 meters above a surface of a swimming pool. At time t seconds, his position h above the surface of the swimming pool is given by h is equal to 32 plus 16t minus 16t squared. Find A, the time he took to hit the water surface, 5 marks. B, the velocity at which he hit the water surface, 3 marks. That is 8 marks in exam. Okay, we say solution. For the question, we say solution. Then we say we have to identify the kind of question. By identifying the question, it's a differentiation question because we are told that the diver finally rested or hit the water surface. Note that when you realize any action where the term at rest is mentioned, know that it's a differentiation question, and we always know that when a particle is at rest, dy dx is always 0. At the water surface, height is 0. We replace h with 0. Hence the height is, hence h is equal to 0. Therefore, we say 0 is the same as 32 plus 16t plus 16t squared. Then we divide the equation through by 16. Hence, we say if we divide through by 16, this is plus. If we divide through by 16, by 16, 1, by 16, 2, by 16, 1, by 16, 1, by 16, 1, by 16, 1. Here we get 0. 16 divided by 0, this is 0. We get 0 is the same as 2 plus t plus t squared. Then we are going to multiply through by the negative. We are going to multiply through by -1 so that we can start with our equation with the highest value of t. We have to multiply this equation with -1 so that we can get the highest value of t here. Therefore, we say t squared minus t minus 2 is equal to 0. T squared minus t minus 2t minus t squared minus t minus 2t minus 2 is equals to 0. Therefore, we are going to factor out t here because it's common. Say t into bracket t minus 1 to brackets minus 2 into brackets t minus plus 1 is equal to 0. Hence, since t minus 1 is common, t minus 1 and t minus 1 is common, we say that we choose 1 and we say t minus 1 into brackets we say not really t minus 1, we say t minus 2, t minus 1 and t plus 1. This is common. We say t plus 2, which is this t minus 2, t minus 2. Then we are going to multiply then with t plus 1, the t plus 1, because which is equal to 0. Hence we say t minus 2 is equal to 0, where t is 2 and t plus 1 is equal to 0. Hence t is -1. The time taken to hit the water surface is 2 seconds. Note that we have ignored -1 time, since time cannot be negative. Hence, the time taken to hit the water surface is 2 seconds. This one, 2 seconds. This is the answer for question number 15A, 2 seconds. For question number 15B, this tells that find the velocity at which he hit the water surface, 3 marks. Those are 3 marks in an exam. From the initial equation, the height h is given by 32 plus 16t minus 16t squared. Note that this is also the displacement, but velocity which is equal to change in displacement over change in time, which should be ts dt. When our height is h, we are going to differentiate h against time. Therefore, dh dt is the same as velocity, which is 0 plus 16t minus 16t squared. We are going to differentiate here because t is power 1 minus 1, t is power 2 minus 1. Okay. For this case, we have dropped 32 because in differentiation, this is a differentiation rule. This is a differentiation rule. That's why we have dropped 32. We have been differentiating this equation here. So there are some students always ask me why did you neglected the 32. We have neglected the 32 because we are differentiating. Now after reaching that step, we say This is the 2 plus 0 is the 2. This will be 16 t power 0, which is the same as 1, minus this is differentiating. This will be 32t. This will further give us 16, and number power 0 is 1, so it's 16 minus 32t. Now, to get the velocity in which he hit the water surface, we need to substitute the time t expression from the initial time he took to hit the water surface, which is 2 seconds. Hence, we are going to say that 16 minus 32 to brackets 2. This will give us 16 minus 64, which is negative 48, which is in meters per second. And this is the answer. But we are going to write it as retardation. Retardation, because he was slowing as he was going down, as velocity was reducing. Note that from our equation we have seen that the diver leaps from, okay, this is the final question for question, this is the final answer for question number 15b, DB. This is the final answer for question number 15b. Now we should note that not all figures must be used in calculating questions in calculus, even if are part of the question. For example, you can see that we have been given a diver leaps from a diving board 32 meters. That 2 meters has never been used for calculating any of these two questions. It has not been used in any of the entire question, and it was just a figure of giving us the information. It was just a figure of giving us information. Now I think we are done with the topic calculus. Next time we are going to tackle other topics like the logarithms. We are going to discuss more on logarithms and other topics. We are done with all this. I think we have, as you can see, we have already, these are how we have tackled the questions. This is how we have tackled the questions. You can get your review. This is how we have tackled the questions. If you can't see the video properly, you can get a review. This is how we have done the questions. Please subscribe, download, and share to your beloved friends and relatives. Download, subscribe, then share to your beloved friends and relatives. Thank you for your